So today we are taking a pause from geometry and doing some algebra. Looking at some products, factors, and factoring quadratics. Some of this stuff you guys will have learned. If you are perhaps taking Algebra 2 right now also, you are learning this stuff. So here we go. So we have some information on this slide, some basics. Product. The product is the result when numbers and or variables are multiplied together. Factors. The numbers and or variables that are multiplied to get a product. So we have a bunch of examples here. 2 times 12 equals 24. 2 and 12 are the factors, and 24 is the product. 3 times 8 equals 24. 3 and 8 are the factors, and 24 is the product. 6 times 4 equals 24. 6 and 4 are the factors, 24 is the product. Okay, we're just reviewing some fundamental vocabulary here. X times x equals x squared. X and x are the factors, x squared is the product. M times n equals mn. Say that 10 times fast. N and n are the factors, mn is the product. 3 times x times 2 times y equals 6xy. 3, x, 2, and y are the factors, and 6xy is the product. These examples are showing us, at least the first 3 on top, that there can be more than just 2 factors of any product. Right? We see the number 24 as factors 2 and 12 and 3 and 8 and 6 and 4. Those are all factors of 24. And that's what I'm saying right here. The greatest common factor. The greatest common factor is the largest factor common to each number or term in an algebraic expression. In the example, we want to find the GCF, the greatest common factor, of the expression 4x cubed plus 16x squared plus 12x. Well, we can see there are 3 terms in this algebraic expression. We have 4x cubed, 16x squared, and 12x. The coefficients, 4, 16, and 12, are all divisible by 4. So we can factor a 4 out. Each term also has an x in it. So we can factor an x out. Factoring out is like dividing. 4x cubed divided by 4x would leave us with just x squared. 16x squared divided by 4x would leave us with positive 4x. And 12x divided by 4x would leave us with positive 3. This is an example of factoring out the GCF. Anytime you factor or are asked to factor, this is always the first thing you want to look to do. Now this algebraic expression can be factored, or could possibly be factored further, and we'll take a look at some other examples to see how that works. All right, next we're going to go over a review of the FOIL method. The word FOIL stands for first, outside, inside, last, and it's used to multiply 2 binomials together. FOIL method is actually just a fancy way to describe the distribution that goes on when multiplying two binomials together. And in case you're not familiar with the term binomial, a binomial is an algebra expression that has two terms. Like a bicycle has two wheels, a binomial has two terms. So our first binomial is 2m minus 7. It has the terms 2m and negative 7. The second binomial, 5m plus 6, has the terms 5m and positive 6. Notice I'm including the sign with the term, right? That's important. So when we FOIL these together, or we multiply them together, all we're really doing is distributing each term in the first binomial to each term in the second binomial. So for example, that's where the f in FOIL comes from. First, we're multiplying the first term of each binomial together. And in this case, we would get 10m squared. Then we would distribute the 2m to the positive 6. Well, this is where the O in FOIL comes from, because the 2m and the positive 6 are on the outside of those binomials, right? The outside being the outside, like that. So when we multiply those together, we end up getting positive 12m. Next, we're going to multiply the negative 7 and the 5m. We're now distributing the negative 7. Well, we just talked about outside. These are the inside terms of the two binomials. So that's where the I in FOIL comes from, for inside. So when we multiply negative 7 times positive 5m, we get negative 35m. And then finally, the last part of the distribution would be multiplying negative 7 times positive 6. Those are the last terms in each binomial. So that's the L in FOIL. And in this case, we would get negative 42. The last step is to combine any like terms, which your two middle terms are both m terms, so we can combine those. Do not combine the m squared term with those. So we get negative 23m in the middle, and then minus 42. Okay, so the next thing is factoring quadratic expressions. And the reason that I just showed you the FOIL method is because factoring is the opposite of the FOIL method. And we need to use the FOIL method to check our factoring. So let's take a look at the first example here. X squared plus 6x plus 8. Now, there are lots of ways to teach factoring and lots of ways to learn factoring. I'm going to show you one. If you already know a different method and it works for you, go ahead and use it. If you learn a different method in the future and you like it better, go ahead and use it, okay? I'm showing you one method, so here we go. X squared plus 6x plus 8. So I start by setting up parentheses, two sets, because I know I'm going to factor the quadratic into two binomials. Remember I told you that factoring is the opposite of the FOIL method? Well, the FOIL method starts with two binomials, and then it gets a quadratic. Well, now we're starting with the quadratic, and we're going to factor it into the two binomials. Right. There are some rules about the next step, how to find the signs, plus or minus, that go in the two binomials. You want to write this down. Pay close attention. If the second sign of the quadratic, so when I read the quadratic, I read x squared plus 6x plus 8. The second sign is positive. If the second sign is positive, then whatever the first sign is, it goes in both binomials. Now we don't have it in our example here, But if the second sign were negative, it does not matter what the first sign is. You automatically have a plus and a minus in your binomials.
Like plus and
So in our example, x squared plus 6x plus 8, we have our binomial parentheses set up, we have our signs, now it's time to factor. From the FOIL method, we know that the two first terms are multiplied to give us this term. So now we're going to factor that term, x squared, to get our two first terms. So factors of x squared are x times x. From the FOIL method, we know that when we multiply the last terms, that gives us that. So we're going to do the opposite. We're going to factor 8. Now we have to take into consideration the fact that we need factors of 8 that will combine to give us positive 6x. So factors of 8 include 8 times 1 or 4 times 2. Well, this is a pretty easy example. We know that 4 plus 2 is 6. So those are the factors that we want to use. We don't want the 8 and the 1. So 4 and 2. And then we always check by foiling. The better you get at this, you can foil in your head. If you're not good enough to foil in your head, write it down. First, outside, inside, last. Combine like terms. That FOIL check matches the original quadratic, so we are sure that our factors of x plus 4 times x plus 2 are correct. Alright, the second example I'm going to go through more quickly, so follow. Start with my parentheses, because I know I'm factoring into two binomials. Look at the second sign. The second sign is positive, so I look at the first sign. The first sign is negative, that goes in both. Now, see this coefficient? It's a 2. In our first example, it was a 1. When this coefficient is a number other than 1, things are going to be slightly more difficult. Pay attention and watch what happens. Factors of 2x squared, well that's not hard, 2x times x. Factors of 7. 7 is a prime number, so it only has factors of 7 and 1. But notice there's no way that 7 plus 1 or 7 minus 1 or anything is going to give me that middle term. That middle term is now impacted by this positive 2 right here in that spot. That's why these become a little harder when that coefficient of the square term is a number other than 1. But I know that if I put a 7 here, the FOIL method will have me multiply that by the 2x. And that will give me 14x. And I have the 1 here, and the FOIL method has me multiply that by the x. And that will give me 1x, and 14x and 1x gives me that 15x. Let's just do the foiling to double check. First, outside, this is what I was referring to. Inside, last, combine like terms. There it is, 2x squared minus 15x plus 7. That matches the original quadratic. So I know my factors of 2x minus 1 and x minus 7 are correct.